Greetings and welcome to another Dev Bootstrapped screencast. In this screencast, I'm going to show you how to build an application that monitors the blockchain for transactions and updates the transactions that were sent to the blockchain to a particular smart contract by a user and display that as a list in a application front end. So the application itself looks something like this. Basically, what we've done here is we have a front-end web application that is connected to a Ganache blockchain, and we are setting and retrieving a value from a SimpleStore smart contract. So this is your very simple smart contract which has one state variable that you can set and you can retrieve it. And we are using MetaMask to basically authenticate accounts with this application. And we are then showing all the transactions that were sent by that user, so by the authenticated user here with MetaMask, to the smart contract that's already deployed over here, and displaying those transactions down here. So this is the SimpleStore smart contract example, which you may be used to already, taken one step further, where we now actually retrieve all the changes that were made over time to that smart contract. And we do this by basically using a Web3 API calls to get blocks and get transactions within those blocks. So I can explain a little bit more using this diagram on a high level of how this is going to work. So what we have here is this web front end, and this smart contract is created using Truffle. And essentially, I used a Truffle box, actually. I used the Webpack Truffle box that's shown here. It's a great Truffle box to use if you want to just get started with proof of concept or showing some examples, or like in this case, a tutorial. Because it's a stripped down, it's a bare bones basic application, no frameworks, no React, no Vue.js, just simple plain old JavaScript with Webpack to bundle it together and to run a dev environment. So back to the diagram, we end up with our front end with our JavaScript application over here. So let's take a closer look at our front end. And what we're going to do on our front end is basically display the value as it currently is. So we're going to read from the blockchain the current value of our smart contract from our SimpleStore smart contract. And we're also going to have a simple form here with a text field and a button. And you're able to basically change the value in the smart contract by typing in a number here or any text, in fact, and clicking set. And that will send a transaction to your local blockchain, your Ganache blockchain, and it will send the transaction to the setValue function in the SimpleStore, and it will update the value. What will also happen is whenever we load this page, so whenever the web page is loaded, or whenever we detect a set transaction has been sent, we will fetch all the transactions from the smart contract or from the blockchain, in fact, to see when and what values those values were set to. And we do that by basically getting all the blocks from the blockchain over here. So we get all the blocks from block 0. And yes, I know this is perhaps inefficient, but again, this is an example, and it's just to show how we could do this. There's naturally many other ways, but what we do in this example is we say, well, give me all the blocks from 0 to the latest. So here in this diagram, we've got 5 blocks, 0 to 4. And for each block that we get back, we want to get all the transactions in that block, because each block has potentially multiple transactions, okay? And so we want to get each block, get each transaction in the block, and then what we want to do in order to know which ones to display here, we naturally want to only display the transactions that came from the account. So this account here that's passed into MetaMask, from MetaMask into the front end app. So we will ignore any other transactions. We only are interested in transactions from this account. And we're only interested when the transactions are going to this smart contract. And so what we end up with are these transactions, which we can then say what happened. And the transaction itself has an input parameter, which is in hexadecimal. So we need to do a little bit of manipulation to be able to convert that hex to ASCII so that we can see the actual value that was sent in the form. So that's pretty much it. That's the high-level overview of how we're going to build this application. So I'm going to head over to the app now and start with building the SimpleStore contract, which should be pretty familiar to all of you guys. And so the first thing I'm going to do is run truffle create contract SimpleStore. And I'm also going to create a migration. So truffle create migration simple_store. And if we open up the contract here, we can see that we've got the SimpleStore contract that was created. And by the way, these other contracts here are actually from the Webpack Truffle box, and we don't need them. So I'm going to remove the contract for convert lib, and I'm going to remove the metacoin as well. Okay, and because I just basically use the Truffle box to create the boilerplate, if you like. So the first thing I want to do in our SimpleStore is have a string, which is going to store the value that we want to keep. All right, so that's our sort of state variable there. In the constructor, I'm going to set the value to some default value when the contract is deployed. So like this, so I just pass in a value and set the state variable to that value. I'm going to also provide a function to set the value. This is what we're going to call from our front end, and that's going to be a new value, okay, which is going to be public. This method or function, sorry, is going to be public. And it's going to set the value to the new value. All right. And then there's finally one more function, which is going to be a Getvalue function, which is going to return a string. And I mean, that should be, sorry, that should be empty. It should be public view returns string, and it's going to return the value. So that's our smart contract, pretty straightforward, right? And we can run truffle compile to make sure that we've done that all nicely. Okay, and then we can check our deployment. So that's, by the way, compiled here, as we can see, compiled successfully. Let's clear that out. Let's remove the migration that we don't want, because that's come from the Truffle box. So that was that one. And instead work on the, focus on the one that we want to use. So const simple store is equal to artifacts require simple store, and we deploy that using the deploy method SimpleStore, and we're going to set it to hello world. That's going to be sort of like our initial kind of state of our variable in our SimpleStore. So at this point, I need to start Ganache, and I need to start up a Truffle Console. Don't need to start a Truffle Console, but it kind of helps. So I'm going to start up a Ganache CLI just to check that that everything is that we can deploy our contracts, right? So then we Truffle Console down here, and I'll make this a little bit bigger here. Okay, and Truffle Console. Okay. That should start up, and we should be able to. One thing I forgot to do, of course, is the networks. All right, so we're going to just remove the comments for the development network. And we can now run migrate reset, and that deploys our contracts. Okay. So now that the contract is deployed, I can check the networks in Truffle Console. And as you can see here, we got the SimpleStore deployed at this address. And I can check this by checking the deployed contract. So I can say SimpleStore.deployed. And I need to put a wait there. And then I can say get value, and we should see hello world. Okay, great. So that was just a quick sanity check. Now that we've got the smart contract part of our work done, so that's the smart contract here, the SimpleStore smart contract, and the Ganache blockchain. So that part there over on the right of the diagram here is complete. We can now focus our efforts on the front end. So the front end of the application is in the Webpack Truffle box is put into the folder app. And if we look at this folder, you can have a look. You can see it's got node modules. It's got a source folder here with an index HTML and index.js. And if you take a quick look at the package.json file, it comes with all of this out of the Truffle box, basically. So you've got the Webpack dev server, build is Webpack. So we can run npm run dev to see this application as it stands right now. So why don't we try that, right? So up here I've got a folder open. So note that I'm basically inside that folder. I'm inside the app folder of the project. And I've already run npm install, so I can run npm run dev. And that will spin up the server on localhost 8080. And notice we get an error, right? It says something like cannot resolve contracts metacoin, blah, blah, blah. That's actually because I haven't changed anything from the original Truffle box. It's still looking for the metacoin contract. So let's just change that to SimpleStore just to get rid of that error and take a look now. So it compiled successfully. So now if we can have a look over on localhost 8080, we'll look at that, and we can split the screen so we can see the console. And as you can see, it still says Metacoin. It's the Metacoin example Truffle app that comes with the Truffle Webpack box. And so naturally what we got to do now is convert this to our SimpleStore front end, this one right here. So we want to change the title, we want to change the values, and we want to add this transaction section and all of that kind of stuff. So what I'm going to do is, for the front end, I'm going to just simply wipe out what we have in index.html. So I'm just going to completely clear it. And I'm going to drop in something I did before, which is this. And as you can see, I've just literally just changed some parameters. So I've changed the title here to what we're working on. I've got the Web3 title here. I've got the SimpleStore value. I've got here a form where we can set the value. I've changed the on-click event to call set value here. And then I've got this transactions section, which we're going to fill out in a bit. And I've got a placeholder here where we're going to put the transactions. And that's pretty much it for the index.html. If we go back to the browser, you can see that it's automatically refreshed, which is fantastic because this is the beauty of using Webpack. But you can see here, it's not showing hello world, right? So up here, it should show me the value of the smart contract. And currently, it's showing loading. So I'm talking about this section here, right? It's showing loading. So how can we fix that? Well, that's obviously in our JavaScript file. So let's take a look at this JavaScript file and go through it line by line to see which parts we need to change. So this file, just to remind you, I haven't changed it yet apart from this bit here. So let's change the name of this first of all so that it matches what we are doing. So it's SimpleStore artifact, okay? And then any time where we have that, I want to change that to SimpleStore artifact. Okay, great. We need Web3 and all of this. This is all fine. We need the network, that's fine. We need the deployed network because here what we're doing is this is the artifact. So it's basically picking up the deployed network of our contract from the JSON in the build directory. So this is good. This is still okay. And we can move down and this is all okay. Refresh balance. Well, the naming there is not quite right. So let's call this something more meaningful, like I don't know, refresh value, right? Because we want to get the value from our contracts, right? And here what we're doing is we're destructing the methods object to get all the methods available on our contract. Remember that this.meta is set here. It's the contract that we're working with. And we don't have a getBalance method on our contract, but we do have a getValue. So let's change that to getValue. And here we're making a call to the smart contract. This was from the box. So now we want to call getValue. And what we want to do is we only want to pass, we don't want to pass anything because in our contract getValue doesn't take any parameters, and we can set that to value. And then here this is just simple DOM manipulation where we're getting the element by class name. And I changed the class name, by the way. I changed it to store value. So this is the element that we want to fetch. So I'm going to use that as our class name that we want to fetch, and it's not the balance element, it is the value element. So let's call this value, and we want to set the enum.html to the not the balance but the value. All right. So I've now finished this method, and so you can see here that when this application starts, it runs this method here, which is going to call refresh value, which is going to run this method here. So hopefully we shall see the value. And we still see loading, but we do see an error here. Could not connect to contract or chain. Now, this usually means that the application is not connected to the right wallet, or that, so I'm connecting, I've got this wallet here open, or that the contract has not been deployed. Now we know it's been deployed, so the contract has been deployed, but let's take a look over here and look at the code and see maybe what the problem might be. I can see this isn't highlighted properly. Yeah, look, it's declared but not read because I've got a typo over here. Should be simple stored artifact. So let's have a look now at our user interface, and that was it. Yeah. So that's an interesting insight because, as I mentioned, sometimes when you get that error, it's usually one of two things. It's usually the wallet hasn't been properly initiated yet, or you're not connected to the right network on the wallet, or even further, you might need to basically click reset account. That sometimes is necessary if the sequencing is out based on the blockchain that you're connecting to. And another very common one, of course, is that the blockchain, the contract was not deployed to your blockchain. But actually, in this case, it was a typo. So that's cool. Now we can move on. So the next thing to do, I think, would be to set the value. So the equivalent of setting value in the MetaCoin one is this sort of setCoin method. And all we need to do really is just sort of change this so that it follows what we want to do for our value. So if we head back to the HTML, The form here has a value label and a value input with ID value. And then there's a button that's on click, and we've changed it to set value. So it's going to call a method in the app JavaScript called set value. So let's change send coin to set value instead. And then here we want to get the value. So it's get element by ID, and we change the ID to value, and we're going to call this value. And we don't need receiver. We're only setting a value. And we can set the status to something different perhaps, but we'll leave it like that for now. It's fine. And then what we want to do is, in this case, we're getting the method again from our contract, which is not send coin, of course. It is set value. Okay, set value takes the new value, so we're going to set that to the new value. Okay, and let's actually change this to new value, because that's what we're getting here. And we still need to send the transaction from the current account, so that's still good. And then instead of calling refresh balance, here we want to call refresh value. All right, so let's check that out. So that should work fine. Let's head over to our browser again, so we don't have any errors. Good. And we got hello world there. So let's change the value to 123 and click that. And if you notice, we got an error. Let's have a look. It says invalid string value, new value, blah 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 type string. So why is that? Why are we getting that error? Well, we're parsing the int, and we are getting the new value. It shouldn't be an int. Of course, in the meta coin, it's an int, but in our case, we're dealing with strings. So let's try that again. So we put 123, and sure enough, we have our notification, which we can confirm. So in this example, we don't need to pay anything. It's not a payable function, but we just need to pay the gas. So if we click confirm, we see that the value updates to 123. So I'll just zoom in a little bit there so you can see that. So that's working. So now we can display the value, and we can set the value. And if we refresh the page, just want to be sure, it loads and then sets and then gives us the value 123. So let's change it just one more time to 999. Once again, we get the Brave notification coming up here with our confirmation from MetaMask, basically saying, okay, confirm the transaction. We confirm the transaction, and then it sets to 999. So that's working. Those two parts are working. So if we head back to our diagram here, basically we've got this section working. We can retrieve the value, and we can set the value. Now for the crunch time, for the exciting part with the transactions. We've got to basically somehow be able to reach into the blockchain and get all the blocks and display the transactions on our application as shown here. So how can we do that? And I mentioned before that Web3 has APIs to be able to get transactions and get blocks from the blockchain. And that's what we're going to basically be using. I'm going to write a method that is going to be called every time refresh value is called, that will basically then also update the transactions. Again, I've mentioned that this could be done in perhaps a more efficient way, but the idea is to basically show this as an example of how to use Web3 APIs to fetch data from the blockchain. In this case, we're going to be fetching the blocks, and we're going to be fetching the transactions within each block, and we're going to be looping through each one, and we're going to do that. So I'm going to say check last block, or we could call this method anything, but really what we're doing is we're checking all blocks up to the last block. So calling it like that, and I'm going to create the method down here, which is going to be a function. What I'm going to do is I'm going to say console log in check last block, And then if we run over to our browser and have a look at our application, you can see it's called in there. And so what we want to do now is start using Web3 APIs in this function to get the last transactions from the user who made those transactions to that smart contract, and then display the value as per our mock-up. So the first thing we need to do is grab our Web3 instance from this, because this is basically our class that we're in, and that basically gives us the Web3 instance, which is a property of our class. And then we're going to grab the latest blockchain, or the latest block number from the running blockchain that we're connected to. So we use Web3 ETH get block number to do that, and that gives us the last. That gives us the latest block number, and we can have a look at that on the console if we like, just to as a sanity check, if you like, and that's going to be latest. And if we look over here, we get an error. Cannot use await, so that's got to be an await function. So we need to put a sync there. Okay, and we should see this refresh. And block number 6. Cool, right. So that means that the latest block in our locally running blockchain is block 6. And now what we want to do is we need to loop through all of the blocks from 0 to the latest, and we'll use a for loop to do that. So standard JavaScript for loop in this case. So we say let I equal to 0. And we say I is less than or equal to latest, and I plus plus. So we increment I for each round. And at this point now we can use the get block method of Web3 to get the block at that index or that block number. So we say Web3 ETH get block. And we pass in I, so that's the block that we want to get. And then we can, what we can do here is we need to now check, does that actually return a block, and does that block have transactions in it? So we can say if block, so that means like, does it actually have a block? And does the block have transactions, right? Because we don't want to do anything if the block is null and if transactions are null, because we need to look in the transactions. Now we can use another for loop, but this time we can use an iterator. So we can grab each of the transactions of the block transactions, like so. And that gives us one transaction at a time. So at this point, we're inside, say, block 0, and we have got the first transaction in that block. And so now we need to use another API call to get the transaction itself. So we can set the transaction equal to Web3 ETH.getTransaction, passing in the transaction that we have at this point. And remember that actually this transaction is a transaction hash that we have here. So the block itself contains, when I say get transactions here, it's actually just a list of transaction hashes, which we then need to get the full transaction through this API call right here. Okay, so now we got the transaction, and the transaction itself contains a bunch of properties, but what we're interested in is the transaction to, the transaction from, and the transaction input. And what we want to do is actually output that, or we want to build a list object to display on our web UI. What we can do at this point, though, let's just for another quick sanity check, use console to log out a few details of this transaction. So let's log out using a template string. Let's log out the 2. So we can grab that from doing this transaction.to, and we can get the from. So we can say transaction.from, and we'll have a look at the input data. So transaction dot input. Okay, and then we'll head over here again and look in our terminal window, and you can see, let's just take one of these ones here. So 2, and then 2 is this address, and from is C0101 B301. So the 2 is the contract address. So I can head over to Truffle and show you that. So the Truffle Console here. We go to Networks. You can see the SimpleStore contract address is 9D, begins with 9D. So that's the contract. Actually, the 23 there, 023.384, if we look at that, that's the migrations contract. So coming back here again, you can see that there's been transactions sent from this account to the migrations contract, as well as to the smart contract that we deployed, the SimpleStore. And you can see the input is this hexadecimal string, and I happen to know that it starts off with a 4 bytes of basically, which is the method, which is the function signature that we're calling. So this will be set value here, and then it contains the actual data that we set following that. So you can see here, I think that must be the 132 that we set earlier, which would be the sorry, the 123 I think we set there, and this is all in hex, so we have to convert this into something that we can read, so we have to convert it to ASCII. So that's just the output in console log. We can hide that for now, but one thing to note is that we only want to display when there is a transaction that is from the current account that we're logged in as. So, because otherwise we don't want to display all the transactions whenever anyone logs in. We just want to display the transactions for the account that's authenticated with MetaMask. So we do this by saying, if the account is equal to the from, then we're good. And we also don't want any transactions where the to is null. All right. And then we can build up our element string. So up the top here, what I'm going to do is I'm going to set a string to 0, and I'm going to start building upon this in here to get our UI element. So I'm going to say, I'm going to add to that string a new list element, so an li, and I'm going to say block, and I'm going to give it a block. I'm going to output the block number, which I know is I at this point, and what I want to do actually is I need to use backticks to make sure that that is used correctly. All right. And then I want to have another line where I have the data that I want to display. And I'm going to actually just copy and paste this in here because it's a little bit of a long string, similar to what I typed earlier. So I got here transaction 2, data, block timestamp. So it gives me the block timestamp. Now, one thing to note is data, I should put here transaction dot input, but I'm going to change this in a minute. I'm going to convert this to something readable, but let's just see if this works. So now we've got our text string here, our transaction string, which is basically our HTML element. We can attach that to our DOM, and we need to attach that right after the loop has completely finished. So once the loop has gone round all of the blocks and all of the transactions in each of the blocks, we finally should have our we should have our element that we can display on the screen. So what we can do is I can get the element by class name, which is tx, which is from our HTML file, and then I just set the inner HTML to the text string. And if we head over to the browser, we should see the transactions displayed here, and we do. That's great. So we can see here that in block 2, a transaction was sent to this contract, and another transaction was sent to this contract with this data at this time, and so on and so forth. So the last real step in this puzzle is to change the data that we show from this hex string into something that's meaningful, so we can see what did the transaction change to. Basically in line with this here, so that we can see that we set it to some value, rather than just showing this long string, this long hex value. The way to do that is to use Web3 again, and a little bit of sleight of hand, if you like. So I basically use the utils hex to ASCII method. I take the input, and I take a slice of that input from position 138 until the end of the input. So the reason why I take from 138 is because there is the function name that is basically the first 4 bytes of the transaction input. There is some other data in the input which is not needed for now, and then the actual value that's passed in is the remaining part of this transaction input in our example, and I prefix it with 0x so that this utility function can convert it from hex to ASCII. And I just need to update this to be the data property that we set here. So we get this now put here, and if we go back to our browser and we see the data is showing here, you notice that sometimes the address is the migrations address, so that's really contract deployment here, so we don't display the data. And you may want to remove these entries if you don't want to show that. So now just a quick test for the full sort of working application. Let's change this to 777 if we click set value, and we can confirm that using MetaMask. Then you can see there it updated with our new transaction, and that's really awesome. So it updated the transaction, or updated the value there, and it added block 7 and a new transaction here. So that's the end of this screencast. I hope that this was useful. All the source code is available on GitHub. Links to the source code will be provided down below. I'll include links to Web3 API documentation, and I want to, if you like, please hit the like button. Please subscribe. There'll be more videos coming soon. And take care, everyone, and I'll see you in the near future. Bye-bye.